Yes, Sat Shri Akal, students. So today we are here to talk about some, uh, you know, some formula derivation, how uh, set theory is useful in solving the questions of probability also. This lecture uh, will help you to understand and do the sums of probability also in a better way. All right, students, first of all, let's talk about two disjoint sets. Let's say I'm having two disjoint sets, A and B. Well, we know that for disjoint sets, there's nothing common between A and B, or we can say A intersection B is a null set because there's nothing common between A and B. So we can define number of elements in the set A union B is equal to just number of elements in A plus number of elements in B. Very simple, nothing else. Now, this, this simply means that number of elements in two disjoint sets where nothing is common is simply the sum of number of elements in the individual sets. Okay, but in case we have any finite sets A and B. Now, when I say finite sets, they may be disjoint, they may not be. There may be something common in them. So I can state number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. So let's understand this by Venn diagram. Very simple. Let's say this is set A and we have another set B. Another set B. All right. Let's say this is represented, let's say in red color. So I will take its elements also in red color, possible, not able to draw. So let's say set B has 2, 3, 4 elements, then 1 element, and set A has, let's say, 7, 8, and 1 element. I can say that 1 element is common between A and B. Now apply here a number of elements in A union B. So A union B set would be defined as 7, 8, 1, 2, 3, and 4. Right? And A set would be defined as 1, 7, 8. What is B set, students? 1, 2, 3, 4.
2, 3, 4.
And what is A intersection B? A intersection B is just 1. Am I right? So number of elements in A union B is 1, 2, 3, 4, 5, 6 is equal to n of A. In A we have 3 elements, in B we have how many elements? Tell me, students. 4. And in intersection A and B, see, I'm going to subtract it. So minus 1. So is it right? 6 is equal to 6 is correct. Okay. So what's happening? I have to subtract this. Why? Because the repetition is not allowed here. That is the reason I subtract this. Okay, that's good. Now I go further and I have something else to show it to you. Fine. So now, students, as we have already stated, what n of number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. This is my first equation. I could say this is my first equation. Once again, let me say this is my very important. This is my first equation. First, not equation, first understanding, first formula. Okay. Now, another thing I want to tell you, students, if you see, if you look at this figures only, can anyone tell me what is set? Once again, what is this set? This set. Anyone out of you? What is this set? Marked with red line. Anyone? So this set is basically A minus B. Do you agree? Because the elements belong to A, but they don't belong to B. One belongs to B. I have not taken this. Only two elements I have taken. And students, please cooperate with me. What is this set? Having only one element, which is common between A and B. What is this set? Come on, students.
A intersection B.
Correct. This is A intersection B. Correct. And what is this set having only three elements, 2, 3, and 4? Yes, Ishma. What is this set? Not including 1. Only 2, 3, 4. What is this set?
B minus A.
This is B minus A. You are not confident? Okay. So, students, can you observe that these three sets, A minus B, then A intersection B, and B minus A, these are disjoint sets. They have nothing in common. Though A and B have something in common, but A minus B, A intersection B, B minus A, these three sets are disjoint sets. I'm going to write here. A minus B, A always, this is generally, universally truth, and B minus A are disjoint sets. Disjoint sets. Am I right, students? Now, if these are disjoint sets, students, sorry, these are disjoint sets. So I can define a number of elements in A union B as sum of number of elements in A minus B plus, what was the second set? Number of elements in A, sorry,
A plus B.
not A plus B, number of elements in A intersection, A intersection B. Plus, what was the third one, Ishma? Number of elements in B minus A. Right. So, number of elements can be considered like this. Okay. Now, students, from this, I'm going to derive the first formula. Let's see how. I can always write it like this. Number of elements in A minus B plus number of elements in A intersection B plus number of elements in B minus A. Students, I am going to add number of two sets, number of elements in A intersection B. Since I've added this, I must subtract this also to respect the equality sign. So I'll say minus number of elements in A intersection B. See, it's something very simple I've done. I've added something, I've subtracted something. Net result is 0. But students, if you see what is this? Number of elements in A minus B plus number of elements in A intersection B. So you see, I'm going to show you. One second. So please see this. Yes. Number of elements in A minus B, 7, 8. And number of elements in A intersection B, that is 1. 7, 8, 1. That is what number of elements in? Can anyone tell? Number of elements in A minus B.
A.
That is number of elements in set A. Similarly, like this, students, we can say, what is this? One second. Number of elements in, I'm including this with this. Number of elements in B minus A. This is B minus A. That is 2, 3, 4. And number of elements in A intersection B is 1. So if I take, if I add these, if I take union of this 1, 2, 3, 4, this is set B, right? So this is number of sets in, number of elements in set B, and this is number of elements in set A. Am I right? Then minus number of elements in set A union B. That is the first formula derived. I have derived from this. Hope you understand. Okay. Write it again. Yes. So I can write it. That is equal to number of elements in A. This whole thing is number of elements in A, which I have shown you, plus number of elements in B minus a number of elements in A intersection B. Very right. This is, again, I have just derived from 3 independent sets, which are disjoint sets, A minus B, A intersection B, and B minus A. Number of elements in A union B. All right. Okay. Now, if we go further, students, let's say, one second. Okay. So now let's assume A, B, C. These are finite sets. These are some finite sets. A, B, C. Okay. Now I'm going to draw the Venn diagram for these. So this is my A, right? And one second. I think I can copy also here. Right? Copy, paste. Yes. Copy and paste. Beautiful. I got 3 circles. So if you just see, students, I'm going to take 3 finite sets. This one. Okay. I'm going to define this them also. This may be taken in black color, right? And this one, this set may be taken in other color. Delete one set also. Okay. Now see, students, this is the I'm going to touch Venn diagram for 3 sets. Okay, Venn diagram for 3 sets. So I'm going to define this, very, very important. Yes, students, just see. So here, my A set is, I take 1, 2, 3, 8 elements. 1, 2, 3, 8 elements in this, right? So like 1 and 2, 1 element is common. This is A set, this is B set, this is C set. So I take 1 element common with B, that is 3. And I take also take 1 element common with C, that is 8. Right? See that, but some space is occupied from B also, so that clearly means that 8 is the common in A, B as well as C. Okay, so one thing is clear that A set has 1, 2, 3, 8 elements, right? 4 elements only. Then I'm going to define the other set B. So B is, let's say, 3, 8, 4, 5, right? 3, 8 already I have written. I'll write 4 and 5 also. Okay, so this is 3, 8, 4, 5. 3, 8, 4, 5. And I'll define C also. Obviously, 8 is definitely there in that. And it has one more element, that's, let's say 10. So number of elements in A is 4. Number of elements here is also 4. Number of elements in C is 2. Right, so I'll write here 10. Yeah, any doubts, students? I've taken A, 4 elements, B, 4 elements, C, 2 elements. So see, between A and B, students, how many elements are common? Between A and B, how many elements are common? 2.
2.
Yeah, between B and C, how many elements are common? Between B and C.
1.
Correct. That is 8. Correct. Between A and C, how many elements are common? Between A and C.
1.
1. That is 8. Beautiful. So this is understood. Now this we couldn't understand yesterday, right? So I'm going to go further now. I'm going to go further. Take a 1 second. Yeah, let's go. Let's go further. So this you're always going to remember this now somehow, that we have defined this now. Okay, fine. So A, B, 3 are finite sets, and each set have something in common with the other. And we have seen what is common with the other set. Okay, we have drawn the Venn diagram also for these sets. Okay, students, can anyone tell me in this case what is A union B union C? Can anyone define this? It's simple. Just take out,
1.
don't repeat the common elements, and just take out the elements of 1. This is the reason. This is the way. 1, 2, 3, 8. Now see the elements of B, but just make sure that they are not getting repeated in A, right? So it will be 3 is repeating 8. No, I will not write 8. 4, yes, 4. I can take 5 also, right? Then from C I will take 10, right, students? So how many elements are there? 1, 2, 3, 4, 5. I think 7. Is it right? Right. And students, here I
Yes.
can also define A intersection B intersection C. Do you understand that? A intersection B intersection C. What is common between all three?
Sir, you have put wrong sign.
I'm sorry. I put wrong sign. I'm so sorry. I'm very sorry. A intersection B intersection C. Can anyone tell me what is common between all the three?
8.
That is only one element, 8. Beautiful. So this is only one element, and A union B union C is 7 elements. Beautiful. Beautiful. That's great. As and when I ask you, you should be responsive. Okay. So now I'm going to define for any A, B, C finite sets number of elements in A union B union C. I'm going to define this. I've already defined this for two sets. I'm going to extend this for 3 sets. Then you can yourself extend this to 4 sets. Not a difficult thing. Okay, so this is equal to number of elements in A plus a number of elements in B plus a number of elements in C. I would request you to write down. Okay, minus number of elements in A intersection B. Okay, then take intersection of B and C minus number of elements of B intersection C. Then take intersection of third one, A and C. Sorry, number of elements of A intersection C. Anyway, I make a mistake. Please tell me. To err is human. And here it is plus, interestingly, number of elements of A intersection B intersection C. Okay. So first we are going to just prove it with numbers, and then we will have other route of detailed proof of this. We're going to prove it also, because once we prove it, there are so many twists and turns we'll be taking, and that will help you in depth in the concepts of this thing. Okay? So yes, tell me how many elements are there in A, union B, C, C, set A? How many elements are there in set A, students? Set,
4.
I'm asking. 4. Very good. 4. So here I write 4. Okay. So I write 4 here. Okay. Then next, 4 plus a number of elements in B, 4. Number of
4.
elements in C, 2. Okay. Now comes minus. So in minus, students, I request you to see what is the number of elements in A intersection B. A intersection B. Can you see?
0.
No, no way, baby. Number of elements in A intersection B. There are 2 elements in common, 3 and 8. Can't you see? A intersection B.
Yes, sir. Yes, sir. Sorry,
Right.
sir.
Don't say like that. Minus 2. Right. A intersection B. Correct. Minus number of elements in B intersection C. I would be happy if Ishma answers. B and C. How many elements are common? B and C. B has 3, 8, 4, 5. C has 8 and 10. So how many elements are common, Arjinder? Only 8. Is
1.
correct. 1 element. Perfectly right. Now minus number of elements in A intersection C. Common in A and C. A and C. A and C. 1, 2, 3, 8.
1.
Here only 8. Correct. Minus 1. Plus number of elements in A intersection B intersection C. What is common between all the 3 sets?
8.
8. So shall I write plus 1? So is it right? 4 plus 4, 8. 4 plus 2 cancels with 2. Minus 1 cancels with 1. 4 plus 4, 8. Minus 1 is equal to 7. 7 is equal to 7, right? So one thing is there that, okay, you know this formula is correct. But just by proving this numbers won't do. I want to prove it in detailed manner. Okay, so here your real patience is tested. Okay, yes, students. All right, let's go further. Are you ready, students? Are you ready? Good. So students, now what you do here, I go number of elements in A union B union C. So students, do you remember the formula? Just now we have derived what number of elements in A union B? What was that? For any finite sets,
Number
not
of
for
elements
disjoint.
of A
Number of elements of A
plus
plus
number of elements of number of elements of B
B, correct, minus number of
minus
elements of
number of
A
elements of A
intersection.
intersection B.
Is it right, Amitoj Singh? Very good. So now I want to play a trick. You take B and C as one set and you take A as one set. And now help me write this. Once again, you take A as one set, first set, and this complete B union C as second set, right? So I can write it like this also. Number of elements in this. Hope you understand. A is the first set and B union C is the second set. So how will I write? So I will write number of elements in, come on, Deep. A, first set, plus number of elements in, what is the second set? B. What is the
B.
second?
B union C.
The second set is B union C. This B union C I have assumed as second set, just like you used to do, remember, like you used to do A plus B plus C. You want to take the square of this. You don't know the square, so you take this as B. So what will you do? A square plus B plus C square plus 2 into A into B plus C, right? Similarly, I'm asking you. Okay. So I have to go a little fast also. Come on. So it will be number of elements in A plus number of elements in B union C. Why? Because B union C I've taken as second sets minus C number of elements in, come on,
A
intersection B.
intersection B union C.
Yeah, A. So it will be intersection. What is the second set? B.
B union C.
Perfectly right. Perfectly right. Okay. So I'll expand it further. You just see. I'll expand it further. So I can write it as number of elements in A plus. Now, this can be again extended. Take this as first set, C as second set. So it will be what? Number of elements in B plus number of elements in C, come on, minus number of elements in, come on, B, see here,
Intersection C.
yeah, B intersection C, perfectly right, minus number of elements in what? A intersection B union C, perfectly right, once again. I'll just push it upwards and then we're going to do the next one also. Okay, so here, till here we have done, right? Okay, next one, yes. Okay, so students, now you just see, you have done n of A plus n of B plus n of C, right? Minus number of elements in B union C minus number of elements of A intersection B union C. Okay. Now, students, concentrate here, please. What is A intersection B union C? So this can be written as A intersection B union C can be written as, yes, students, this can be written as A intersection B. Can anyone complete this? Union A intersection C, right? A, you can take A, B, C, again the sets we have taken and try to do it, you will prove it is correct. A intersection B union C is equal to A intersection B union A intersection C. All right, if this is the case, then I can write this one. What? Number of elements in A intersection B union C is equal to what? Students, can you? Number of elements in A intersection B union C. So this will be very simple. See this. A intersection B union C, I've already written as, consider this as first set and consider this as second set. And again do the same. What? If this is first set, this one. And this one is the second set. Amitoj Singh, you are understanding? This
Yes,
as
sir.
a first set, this as a second set. So
Second set.
number of elements in this would be equal to number of elements in the first set. What is first set? A
intersection B.
Perfectly right.
Intersection.
Plus, what is the second set? Number of elements in A intersection C. Can you tell me what will come next?
Minus number of
Minus
intersection
number of
intersection
elements in,
B.
correct. A intersection B. What is A?
Intersection B.
A intersection B. Right? Then tell me, intersection
Intersection.
A. Tell me, intersection C. Perfectly right. Is it right? Is it clear? See, I've just taken this as
Yes,
first
sir.
set and this as second set. Okay. Right. Now, also, students, just see. N, this is equal to N A intersection B plus number of elements in A intersection C. Students, just see what is this. A intersection B, that means what is common in AB. Intersection A intersection C, what is common in A and C. Don't you think this is equal to what? A intersection B intersection C. Just see what is common in AB and what is common in AC. And now he is asking what is common in both the sets. So that is that 8. Are you able to understand? That we had drawn the Venn diagram before now. 8 is the common.
Yes,
So this
sir.
is right. So this is what number of elements in what this whole thing can be written as A. Tell me, intersection B intersection C. I'll give you an idea. Again, I have already defined A, B, C. I don't have time because Zoom is going to finish. So you just put the values, you'll find this is correct. Okay, fine. So I'll put this value here, and what I get, just see. I'll put this value here. I'll put this value here. So what do I get? See, students, this is my this is from where I had started. What number of elements in A? Tell me, union. And now I remove the bracket. I remove the bracket just to make me understand that B union C is a second set. But I now remove the bracket. A union B union C is equal to, tell me, what is this? Samitoth Singh, number of elements in A plus,
A
what is
plus
this?
number of elements in
Number of
B.
elements in B plus number of elements in
Number of
C
elements in C
minus
minus
number of elements in B intersection C.
B intersection.
This one. And what is this I have derived?
A
This is
number
equal
of
to,
elements of A
so
intersection B.
I will just put a whole bracket, right? So I will write n of A intersection B plus number of elements in A intersection C minus number of elements in A intersection B intersection C. Am I right? So I'm going to open the bracket now.
Yes, sir.
See what happens. Number of elements in A plus number of elements in B plus, tell me students, the more you speak the better it is. Ishma, you also speak.
Number of elements
in C. Now I put this first and this will be minus sign. So minus number of
Yes,
elements
sir.
in A. Keep speaking. Keep speaking. You will get benefit.
Intersection B
A intersection
minus A
B
number of elements
minus number of elements in B
A
intersection C. Right now here automatically minus will come. See, this is plus, minus will come, right? Minus number of elements in A intersection C, and here minus is there. So what will come, Arjinder? Minus will become plus. Plus number of elements in A intersection B intersection C. Okay, so with the grace of God, we have derived the formula. If you have three sets, finite sets A, B, and C, A union B union C would be equal to this. Hope you get my point.
Yes, sir.
Hope you got my point. This is really good. Very good thing. You have derived a good what? Actually, we have not derived a new law. We have only, twisted the things and gone a little bit more in the depth of this, right? So we can say what, students? Number of elements of A union. Yeah, can any student speak it? We still have less than 1 minute. A union B union C is equal to,
yes, sir.
In A, in B, in B, C.
Number.
Take intersection of A and B, B and C, A and C. Then add the number of elements which are common in A, B, and C. Thank you very much, students. Don't forget to like Learn CBSE, our YouTube channel. Learn CBSE, and we would request you to subscribe it and press the bell icon. Thank you very much.